Hey everybody! Welcome to another exciting edition of Math with Mr. Reeves. Today we're going to be talking about scientific notation. I'm wondering if you ever put a problem in your calculator. I'm going to go ahead and pull up my handy dandy calculator here, and you had some really big numbers. So I'm just going to 967 4 3 5 2 6 1 8 times 8 5 2 1 4 9 6 9 7 8, and you did a problem like that and you put that in your calculator, and then you got something that looked like this. And you're like, I don't know what that means. What does that mean? Well, what this means is 8.24397035 times 10 to the 18th power. Your calculator has a limited amount of space, and you guys know when it gets really big numbers, you have many powers of 10, right? You all remember from elementary school when you learn place value, right? You have the tens, and then the hundreds, and then the thousands, right? And then you have the 10,000s, and then the 100,000s. Every one of those place values represents a power of 10. So what this says is the answer to that problem has 18 powers of 10 after this original decimal point, right? So it would be an 824, and it would go 18 places. So the calculator doesn't want to do that. All right, people don't like writing out all those zeros or all those place values. So they invented this method of writing numbers called scientific notation. So I am in your textbook in lesson 15.2 in the Accelerated Math 7 textbook, and it says scientific notation is a method for expressing very large, that's what we were talking about, but also very small numbers, all right, as a product of a number greater than 1 and less than 10 and a power of 10. So if it were a very small number, we'd be going the opposite direction, right? And we would have, remember when you learned place value after the decimal, you have tenths, hundredths, thousands, 100,000s, and so on. So scientific notation is a way to write very large or very small numbers, and you start with a number that is greater than or equal to 1 and less than 10, and you multiply it by a power of 10. All right, that all sounds very confusing, but you know what I have to say, that scientific notation historically has been one of the things that students really do understand well. So why don't we just dive in and take a look at some examples and see how scientific notation works with large numbers, and then we'll take a look and see how it works with small numbers. All right, so we have a number here, right here, 84,000, which is not really that great of a number, but we certainly can see that we have lots of zeros here. We have 3 zeros, and if we want to write this number in scientific notation, here's what we're going to do. We're going to start at the end where the decimal place is. All right, now we don't normally put a decimal place there or a decimal point there, but that decimal point actually is there, right? And then we move it back 1, 2, 3, 4, and we stop there. Now, please know we could stop anywhere. We could stop there if we wanted. We could stop there. We could stop there. We could stop there. But then it wouldn't be in scientific notation. In scientific notation, this number that you have here, all right, it has to be greater than or equal to 1, and it has to be less than 10. All right, so a lot of times we say between 1 and 10, but it can't be 10 and it can be 1. So greater than or equal to, all right, so greater than or equal to 1 and less than 10. So 8.4, do you agree, is greater than or equal to 1 and less than or equal to 10? Times 10 to the 4, because this is 10 to the first, 10 to the second, 10 to the third, 10 to the fourth, right? 10 to the fourth power is when you have it right here. We went 1, 2, 3, 4. We moved 4 places. So 8.4 times 10 to the 4th is 84,000. All right? Alrighty, so that's how you change a number into scientific notation. Right here, we have 3, 6, 7, right? 6 places is a million, so I think this would be 93 billion. All right, 93 billion is the distance from the Earth to the Sun in miles. So we would go, here's the decimal, right? 1, 2, 3, 4, 5, 6, 7. And again, why are we stopping here? We're stopping here because 9.3, right, is greater than or equal to 1 and less than 10. That's where we stop. Okay, again, a lot of times we say between 1 and 10, but that's really not quite correct because 1 is allowed. Okay? All right, and then we say how many places did we move the decimal? We moved it 7 times. So our answer is 9.3 times 10 to the 7th power. That is, this by the way is called in standard form, and this is scientific notation. So it says write each number in scientific notation. So here's where my decimal is on these, right? I'm going to go 1, 2, 3 places, again, because 6.4 is greater than or equal to 1, but less than 10, times 10 to the, how many places did I go? 10 to the 3rd. All right, by the way, as far as multiplication goes, you know, algebraically, we like to use a dot for multiplication, or we use parentheses, or when we have variables, we can just write them next to each other. All right, but in scientific notation, I'm going to go back to the old way, and I'm going to go with an X for the multiplication, and the reason why is because this is a decimal, and when you put a dot here, sometimes it could just get confusing, okay? So that's why I go ahead, even though normally I would say let's move away from the X for multiplication, we're going to use it for scientific notation, okay? But if you do see a dot, that still is in scientific notation. I'm just curious. Let's go back to the calculator. With the calculator has the star for multiplication, right? Alrighty. Here we go. 570. Let's see. 3, 6, 9. Oh my goodness. So we have million, billion, trillion. What do we got here? All right. So I'm going to go 5.7 times 10 to what power? 3, 6, 9, 10, 11. 5.7 times 10 to the 11th power. All right. So that's how you convert a very large number to scientific notation. What about going the other direction? All right. What about if a number is in scientific notation and we want to write it in standard notation? So this one right here is in scientific notation. Now they want us to go the other way because maybe you got this on your calculator and you need to know how to write it not in scientific notation. All right, so here we have our number 7.034, which is our number that is greater than or equal to 1, but less than 10. And we know we want 10 to the 9 places to multiply that by 10 to the 9th power. Well, if I move it here, that's 10 to the 1st power, that's 10 to the 2nd power, that's 10 to the 3rd power. So when I change it from 7.034 to 7,034, I have multiplied by 1,000, right? That's 10 to the 3rd. But as you guys know, 10 to the 3rd times 10 to the 6th is 10 to the 9th, right? We just learned that with our exponent rules, right? So I need to go 6 more places. 1, 2, 3, 4, 5, 6. And that's where my decimal is going to go, right? I should probably make this my decimal point red. And what do I do with all those empty spaces? I fill them with zeros, okay? So I get the decimal point is no longer there, right? Let's see if I did this right. I got 3, I got 6, I've got 9, right? There's my 9 decimal places after my original 7 right here. Where the decimal was, I've moved it 9 places. So this one right here, okay, I'm going to go ahead and write 2, 3, 6. There's where my decimal place was. I need to go 5 places, right? 1, 2, 3, 4, 5, right? It was here. 1, 2, 3, 4, 5. So I get 236,000. So 5 times 10 to the 6, that would be the same as 5.0 times 10 to the 6, right? So I have 5, I need 6. 1, 2, 3, 4, 5, 6, right? There we go. So there's the 5. That's where the decimal place was. And then I put 6 zeros after that. All right, so that's what you do with really big numbers. When you have really big numbers, you're going to have a positive exponent because you're going to the right. All right. By the way, the textbook talks about something called calculator notation. Where's the problem with calculator notation? Maybe this textbook doesn't do it. The 8th grade textbook did it. Sometimes in a calculator, sometimes you will see E. So you'll see something like 10E6, okay? All right, that would mean, let me do something like this, 7.14e to the 6. That E, that means times 10 to the power. So if you're using a calculator that does that instead, again, my calculator that I am using, and the newer calculators tend to have bigger displays, and they do times 10 to the power. But older calculators, if you see that E, that indicates that it's times 10 to that power, right? So this would be 7.14 times 10 to the 6th power. I just wanted to bring that to your attention. I thought it was here, but I guess it's not. All right. Now, writing scientific notation with negative powers of 10. When are we going to have a negative power of 10? Well, let me quickly remind you of something we just learned recently, right? Remember when I was talking about powers of 2, right? And we said 2 to the 0 is 1, and 2 to the first is 2, and 2 to the second is 4, right? And 2 to the negative first power was 1/2. And 2 to the negative third power is 1/4, and so on. See how with these negative exponents, we're dividing now, right? And our numbers are getting smaller and smaller and smaller. As long as our base is a whole number, when you have a negative exponent, it's going to get smaller and smaller. Well, we are dealing with powers of 10 now, right? So 10 to the 0 power is going to be 1. 10 to the first power is going to be 10. 10 to the second power is going to be 100, and so on. 10 to the negative power is 1/10, or as a decimal, right, that's 0.1. And 10 to the negative second power is 1/100, or as a decimal, that's 0.01. So can you see when we have negative powers of 10, we're getting these decimal answers? So if we want to take a decimal, a small decimal number, and change it to scientific notation, that's when we're going to get these negative powers of 10. Because negative powers of 10, you're repeatedly dividing by 10 or multiplying by the reciprocal of 10. I have to tell you, it's a little trickier to work with. It's a little bit trickier to write smaller numbers in scientific notation. All right, but let's focus on where the decimal is. You always start where the decimal is, okay? And we want to come up with a number at the beginning that, remember, we're looking for a number that is greater than or equal to 1 and less than 10. So when I start with this decimal, 0.0783, I have to go 2 places, and then I get my 7.83. 7.83 is between 1 and 10, but remember, we can't really say that because it includes 1. All right, basically, guys, you're looking for one number before the decimal. 7.83. Now, how many times did I move the decimal to get there? I moved it 2 times. But if I put 7.83 times 10 to the second, that would be a big number, right? Well, not that big, but this is a smaller number. So again, when you have a smaller decimal number, you're looking for the negative exponent. Because what do we really have here? We have 7.83 times 1/100. Isn't that what 10 to the negative 2 is, right? 1/100. And if you have that, all right, you'd have 7 0.83 divided by 100, and then we know when we divide by 100, we need to move the decimal 2 places to the left, right? Hopefully you learned that a while back. Alrighty, so let's look at converting some numbers, small numbers, into scientific notation. So again, you always start where the decimal is. All right, and this time I have to move it this way. 1, 2, 3, 4, 5 places. 8.29. So here's my number that is greater than or equal to 1, but smaller than or equal to 10, times 10. How many places did I move it again? 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5 places, but I can't write 10 to the 5th because that would be a big number. I'd be multiplying by a big number. It's 10 to the negative 5. It's a small number, right? Again, 10 to the negative 5th is 1 over 10 to the 5th, right? Which is going to be 0.00001, right? That's what we're going to get there with 10 to the 5th power. Alrighty. Okay, what about this one? Again, we start where the decimal is. 1, 2, 3, 4, 5, 6, 7. So 3.02 times 10 to the negative 7 power. Okay, again, 3.02 because it is greater than or equal to 1, but less than 10. Power of 10, they're always powers of 10, to the negative 7th power because this is a small number, right? That's what makes that decimal number. Small decimal numbers will always have negative exponents. Big numbers will always have the positive exponents. Again, we're talking with powers of 10 here. All right, so right here we go. 1, 2, 3, 4, 5, 6. So I get 7 times 10, not 10 to the 6th, 10 to the negative 6th power. And of course, we need to be able to go the other way as well. Given a number in scientific notation, we need to know how to change it back. Okay, so this is where you got to be really careful. First of all, think. Exponent is negative. What kind of number should I get? I should get a small number. I know I need to move the decimal 6 times, so I'm going to write 1.045. Now, if I move it 6 times this way, what kind of number am I going to get? I'm going to get a big number. I need a small number. So I'm going to write 1.045, but I'm going to move that 6 places not to the right. I'm going to move it 6 places to the left. So there's 1 place, right? 1, 2, 3, 4, 5, 6. Now my decimal is here. And now what do I do with all those empty spaces? I fill them with zeros, and then if I'm a really super duper good math student, I put 1 more 0 in front of the decimal place, right? Okay, so I have 0.000001. All right, and I just want you to be careful here. Notice how many zeros do I have, not counting this 0 here. 1, 2, 3, 4, 5 zeros. When you're going to the left, you can end up with 1 less 0 because you have to use 1 to get there, right? When you're going to the right, you get that many zeros if there's nothing there. So don't count zeros. Don't put 6 zeros here. If you count this 0 here, it'll be 6. Okay, so if you include this 0 before the decimal, 1, 2, 3, 4, 5, 6. It'll work out that way if you include that one. All right, 9.9 times 10 to the negative 5, right? So I go 1. I've already used up 1, 2, 3, 4, 5. There's my decimal, right? 1, 2, 3, 4. And if you put the 1 in front, that'll get you your 5 zeros. But there's only 4 after the decimal place. All right, 1 times 10 to the negative 2. So here we go. This time we're only going 2 places. 1, 2. Put your decimal. And again, if you include that 0 before the decimal, there's your 2 zeros there. All right, so that's kind of hard to see what that one is. That 0.015. 1. We don't really need that 0 there, do we? Okay, 0.01. All right. Okay, well, I hope that helps you have an understanding of scientific notation, both for really big numbers and really small numbers. I still was looking for those problems with calculator notation. They must have pulled those out. But again, guys, if you're using... Maybe it's over here in this section where it starts talking about operations. We're going to be talking about adding, subtracting, multiplying, and dividing in scientific notation. And maybe that's where the calculators are going to come in. All right, that's all I have for today. I hope this was helpful for you. But if not, remember, you can always ask for more help because I am here for you. Have a great day, everybody. See you next time. Bye.